All right, today let's talk about the Pythagorean Theorem. So the Pythagorean Theorem is probably one of the most well-known, easily remembered theorems there are in mathematics. I'm pretty sure if you were to say, hey mom and dad, what's the Pythagorean Theorem? They'd probably be able to answer you. So let's go about what is the Pythagorean Theorem. Well, first off, the Pythagorean Theorem is named so because it was a man named Pythagoras who lived during the times of ancient Greece that came up with it. He was a mathematician who had his own school, and his school was very famous and it was very groundbreaking because they were one of the few schools that allowed women to attend. And they were also considered a sect, or I guess somewhat like a cult, because he had a lot of rules that his students had to follow. One of those rules that they had to follow were that they couldn't eat beans because they believed that if you farted, a part of your soul would leave your body, right? So it's one of those weird, idiosyncrasies that these mathematicians had. All right, so back to the Pythagorean Theorem. Now, first off, to understand the Pythagorean Theorem, you have to know that it only applies to right triangles. And right triangles are the ones that have a right angle or a 90-degree angle. So again, that square right there, that is your right angle, also known as your 90-degree angle. So this only works as long as you're working with triangles that have that 90-degree angle. Now, the parts of the triangle are also important to know as well. Notice that this side, which is opposite of the 90-degree angle, is the longest side. We call this the hypotenuse. And the two smaller sides, we call these legs. So the Pythagorean theorem is a squared plus b squared equals to c squared. So how do these variables relate to the right triangle? Well, simple. Think of it as leg squared plus leg squared equals to the hypotenuse squared. So if you had a triangle, right triangle of course, that had sides of 3, 4, and 5, where 5 is the longest side, your hypotenuse, you would write this as 3 to the power of 2 plus 4 to the power of 2 equals to 5 to the power of 2. And we could test to see, is this a right triangle, right? So again, Pythagorean theorem does many things for us. It helps us discover whether or not a triangle is truly a right triangle. And if it is a right triangle, it can help us discover missing side lengths. So right now what I'm doing is I'm going to try to see, is a triangle with side lengths of 3, 4, and 5 a right triangle? So we know 3 squared is 9, right? 3 times 3. 4 squared is 16, 4 times 4. And 5 squared is 25, 5 times 5. Does 9 plus 16 equal 25? Yes, it does. So that's how we know that this triangle for sure is a right triangle, because the Pythagorean theorem worked for its side lengths. Now, let's say I want to find a missing side length. So let's say I had a right triangle. And let's say that this side was 1, this side was 2, and I don't know what the hypotenuse length is. Okay, so I'm going to now use the Pythagorean theorem to help me figure out what's the length of that missing side. So I can use 1 squared, right, plus 2 squared equals to x squared. So let me turn to the next page here. Okay. So we have 1 squared plus 2 squared equals x squared. All right, 1 squared is 1 plus 2 squared, which is 4, equals to x squared. Add 1 plus 4 together, you get 5. Now, we need to get x by itself. And if you remember what we talked about when we were trying to find the principal square root, we're going to go ahead and take the square root of x squared and 5 to get x. Now remember, the only time we do negative square roots is if there were a negative in front of the radical sign, but there's not. So we're going to give the positive answer, even though we know that there are 2 square roots for every number. Now, the square root of x squared, that equals to x, right? Because the square root, the radical sign, and the power of 2, they kind of undo each other, right? It's like you're taking the square root while raising to the power of 2 at the same time. They undo each other. Square root of 5, I'm not really too sure about that, so I'm going to have to use a calculator to figure that out. So let's go ahead and do that. All right, using my lovely wife's amazing pink calculator here. Okay, square root of 5, right? So I'm going to go ahead and press the second button to give myself that radical sign. I'm going to go ahead and punch in 5, close out the parentheses, and I get 2.236067977. Now I'm going to guarantee that number goes on much further than that, because this is what we call an irrational number, okay? And we can talk about that more later on. Now, do I want to write this entire number down? Depends, right? I'm not going to write the entire number down, but sometimes problems will say, give your answer to nearest tenth, give your answer to nearest hundredth. Typically, it's going to be nearest tenth or hundredth. Remember that this is tenths place, hundredths place. So I can write my answer as 2.2. Now, it's 3 here, but notice there's a 6 right there. So we're going to go ahead and round up. So instead of 3, we'll put 4, because this number is closer to 2.24 than it is to 2.23. And that would be my answer for x. I could also leave my answer as radical 5 as well, if the question allows for it, meaning the question says leave your answer, in the form of a radical. Now, we went ahead and used the Pythagorean theorem to find out what would be the value of a missing hypotenuse, right? What if we were missing a leg length? Okay, so let's go ahead and take a look at that. So let's say we had a right triangle here. Okay, and I knew what my hypotenuse was. My hypotenuse was 7. Okay, I knew what one of the legs were. One of the legs were 2, but the other leg I'm missing, right? So I need to use the Pythagorean theorem to help me find out what is the value of the missing leg. So we'll set this up. I'll go ahead and take x squared plus 2 squared, right? Leg squared plus leg squared equals to 7 squared. All right, now let's go ahead and use it. So this is still x squared, and then 2 times 2 is 4, and then 7 times 7 is 49. Now I'm going to go ahead and get x by itself. So I need to move this 4 over here, right? I need to get x squared by itself. So I'm going to go ahead and do the inverse operation. I'm going to do the opposite. I'm going to subtract 4 from both sides. When I subtract 4 from this side, that leaves the x squared by itself, because 4 minus 4 is 0. On this side here, 49 minus 4, I get 45. So now I go ahead and take the square root in order to figure out what x equals to. So I'll take the square root of x squared, which leaves me just x. I'll take the square root of 45. Okay, let's see here. Square root of 45 is 6.70820392. So I'll go ahead and round it up to 6.71. And that would be my answer. All right, so we've gone over the parts of our right triangle. We've talked about the Pythagorean Theorem, a little bit about Pythagoras himself, how a right triangle has legs and a hypotenuse. And the hypotenuse is the word we use for the longest side of the triangle. And then we talked about how the Pythagorean Theorem is a squared plus b squared equals c squared, where it's the two legs squared added together equals the hypotenuse squared. And we use that to help us figure out, one, if a triangle is a right triangle, two, the missing length of hypotenuse, and three, the missing length of a leg. And I think you are ready to go. All right, see you next time.